So, now that we have come to the end of this 20 hours long course, so we can look back and see and summarize that what all we have covered during our lectures and what are the things possibly we have left out and may be important for some of you. Okay? So, let us very quickly do a summarization. First, let us look at the topics that we have covered. Verilog languages and features. Well, here we looked at the various syntax and semantics of the Verilog language. Syntax means the rules for writing the statements, the modules, and semantic means what each of the constructs means. So, using these basic constructs, you are able to write simple models, even more complex models. So, models of various complexities can be created and you are getting a platform where you can develop more complex designs. Okay. Then in particular we looked at the difference between behavioral and structural representation, which is very important in the context of design. So, towards the beginning of the course we mentioned that the normal design practice is to start with a behavioral representation of your modules, because it is much easier to do it that way. See that the overall structure and the interface of the modules is correct. Those behavioral blocks you can instantiate in a high level module, and then whichever of those modules you want to represent in a structural form, you can step by step go ahead and do it. Not necessarily everything in one go, that also you can do it in a structural way, in a not structural, in a hierarchical way. Like for example, I gave you an example of an adder. Well, adder is a very high level entity. Next level you can say that I am using 4 full adders to build a ripple carry adder. Next step, I can actually have the structural design of a full adder. So, we can do it in a hierarchical fashion also. Okay. Then we took a number of examples and tried to explain what the continuous assignment using the assign statement really means and where in Verilog code we should use it and when. Well, as I said, these kind of assign statements are not used inside procedural blocks like always or initial, they have to be outside, and they usually are used to represent combinational logic blocks. So, we saw the various different techniques and styles for modeling both combination and sequential circuits, and we looked in detail inside the procedural blocks and the differences between blocking and non-blocking assignments, which of them to be used when and why, and when you also looked at some of the good and some of the not so good practices. You should not mix blocking and non-blocking assignments within a single block, for example, and there are some other constructs also we talked about. There are a few things that should be avoided. And of course, when you write a Verilog module, the first thing is that to check whether the module is more or less working correctly or not. So, writing test benches and simulating it is the first step for that. Well, I am saying more or less because writing a test bench and running it does not mean that everything is correct with your module. In the test bench, you are possibly applying only a few inputs and checking the outputs. Well, exhaustive checking for very complex designs may not be possible. It may take quite a long amount of time. Okay? Fine. Then some other advanced topics that we looked at were modeling of finite state machines. There we saw how we can separate out the data and control paths, design them separately. Okay. Then we looked at user defined primitives, switch level modeling. These are of course something very specific which I mentioned many of the synthesis tools may not support. So, these are more for academic interest, more from the point of view of modeling. Again, initially when you are modeling something in a high level in behavioral form, maybe you can use a UDP, user defined primitive, for modeling it, but later on you will be converting it into a structural representation later on. Okay, fine. Then we talked about pipelining, what are the basic concepts, and in particular we looked into the detail of a pipeline implementation of MIPS32 instruction set, actually a small subset of it, and we saw through some examples how we can actually activate the data path, pipeline data path we have designed, and we can verify that our processor is working correctly by checking the output by feeding some inputs. Okay. So, there are a few things which I have not covered because they were slightly out of scope of this course, because in this course here our target was to give you an exposure to Verilog language, not exactly to the environment where you will be utilizing Verilog language, like for synthesis for example. So, we have not talked at all about synthesis, we had not talked about the synthesis tools that are available, that is beyond the scope of this course. Okay. So, the use of the synthesis tools maybe for FPGAs and for ASIC implementations, there are so many tools available. For FPGAs you have tools from Xilinx, from Altera. For ASICs you have tools from Cadence, Synopsys and other CAD vendors. And of course, whatever examples we took in such a way that it is possible to convey the design to you on slides or through some codes. We have deliberately not looked into very complex designs. So, you already have very good books available on Verilog, and there is a huge resource available on the internet. If you do a search, you will be getting lot of interesting materials on design. And of course, the last thing I want to emphasize very clearly, that you cannot be an expert by just attending a 20-hour course. This is just an introduction to Verilog. I just told you what is Verilog, how to write simple codes using that. But when you are going into a real design, if you are a serious designer, you will have to look at a lot of more nitty-gritties, lot of more issues, and only then you can become a expert or good Verilog programmer. So, at this level I would say you are still a novice. So, once you do practice on designs, then only slowly you can gain in expertise. So, expertise comes from experience. So, if you handle complex problems, this can give you a lot more insight than any textbook can teach. For example, in our last lecture we talked about pipeline implementations. There we saw that we need some variables called halted and taken branch, so that for certain conditions we may have to switch off some of the writes or updates to memory or registers. Now, these can come only after you start your design. So, there will be no textbook or no ready-made source that will tell you that, well, if you do all these things, whatever you write will always be correct. It is never so. Whenever you write a complex thing, whenever you create a complex design, to start with there will be lot of errors, lot of confusions coming. You will have to sit down with it, analyze it, understand it, and slowly come up with a solution, slowly rectify the errors. Only then you can be a good designer. Well, if you see that I have written something and means in first go everything is running, then unfortunately you have not learnt anything. So, unless you are stuck and you spent lot of time in debugging your error, only then you can become a, you can say, expert debugger, I should say. So, if there is some hurdle, how to cross it, you will be able to understand. Okay. So, let me hope all the best for your future careers and future endeavors. With this we come to the end of the course, and thank you very much for attending.